Take two. Okay, so we are going to take up the homework from yesterday, so excuse that. All right. So the mass of aluminum actually produced. Now, what do we have to use for our other reference point? Because we actually have 10 grams of aluminum that's there, but we're trying to find out how much actually gets used up. Okay, Alfred?
Aluminum chloride?
Nope, not aluminum chloride. Copper chloride, copper 2 chloride, good. And because yesterday we determined that that was the what? Yeah, limiting reactant, very good. Okay, so everything's going to be set in reference to that. Okay, and then that's Al there, and that's MCuCl2 there. Okay, and away we go. All right, so if I get my shout outs. Our mass of aluminum and our mass of copper 2 chloride. Well, how many grams did we actually have? We actually had 10, that's right. Now, we actually do have 10 grams of aluminum, but again, not all of it's going to react because copper 2 chloride is going to run out first before aluminum chloride, or before aluminum is done being used up. This would mean that if we did this reaction, all of that blue would disappear, and there would still be aluminum foil, like silvery looking aluminum, left over in your reaction vessel. Okay? And that's an important thing to realize, is how that actually looks when you're doing the real experiment. Okay, what was our mass of aluminum for our equation? Let's jump back. It was 53.96 grams. Good? Oh shoot, I don't have my calculator up here. I'll need your help. Okay, and our mass of copper 2 chloride was 403.35. So, our mass of aluminum that actually got used is 10 times 53.96 divided by 403, and what do we get? Let's calculate, please.
50, no, 10 times 53.
So we go 10.00, but we don't have to go 0.00, times 53.96 equals that, divided by 403.35 equals 1.34 grams used. Okay, so our next question then, how much is left over? So that was question A. Question B. Yeah. So our mass of aluminum that's left over is equal to, yeah, the mass of our total that we had to begin with minus the aluminum that actually got used in the reaction. So 10.00 grams minus 1.34 grams. Should be able to do this in my head, but I'm not going to, just in case. That's what I thought. 8.66 grams of aluminum. Okay. So all of that 10 grams of copper 2 chloride would have been used up, and you would have, well, if you think about it, 86.7% or 86.6% of your aluminum didn't get reacted. So we could keep doing that reaction. We'd have to add in more copper chloride to begin with. Okay? So when we did this reaction, I just scooped out random amounts, and I gave you random amounts of foil, and I said, go at it, and some of you had it completely actually, if you recall this, some of you guys completely reacted off all the aluminum, and some had some left over, if you remember that experience. It just depended on the group, and how much concentration was for each. And so that's that question. Okay, so we knocked that one out of the ballpark. And then how many grams of copper is actually produced? Okay, so now we got to go back, and again, we're going to put everything in terms of copper 2 chloride, because we can't use the 10 grams of aluminum All right, unless we change this, but we're not going to. So our mass of copper actually produced divided by the mass of copper to chloride, which was completely used, right? And that gives us the mass of copper here and mass of CuCl2 there. So far, so good, right? MCU divided by 10.00 grams equals, what was our mass of copper? Back to our chart, 266.67. And 403.35? Is that right?
Yes, that's right.
Okay, cool. Sweet. So, our mass of copper that was actually produced. So, let's see here. .61 grams actually produced. Okay. Now, had we used our mass of aluminum for that, that would be much bigger, obviously. Okay. All right. So there's your answer, and that's our solution.